Look at your hands. Look at the solid ground beneath your feet. Your human brain, shaped by millions of years of biological evolution, tells you that reality is a physical place, made of smooth, continuous matter that you can touch and trust. We assume that space is an ocean without end. Our intuition suggests that with a ruler, we could divide a measurement in half forever, or that a spaceship with enough fuel could accelerate through the void without limit. But the equations used to define our world behave differently when pushed to their absolute mathematical extremes. At the edges of the very small and the very fast, the conventional rules of a physical realm begin to break down. At these limits, the cosmos ceases to behave like an organic environment and begins to mirror the behaviors of an overloaded digital system. To test if we occupy a simulated reality, we don't look for a physical plug. We look for the constraints. By identifying the exact mathematical limits of the universe, we can determine if we are living within a system defined by its processing power. The speed of light is the absolute maximum speed at which any information or causal event can be transmitted through the grid of spacetime. It is the universal limit on the movement of any particle. In computer science, a central processing unit is restricted by its clock speed, the maximum rate at which it can calculate data. If the universe is a simulation, the speed of light represents the hardware limit of the rendering engine. The system simply cannot update the state of reality faster than this specific number. The most prominent proof of this limit is the phenomenon Einstein identified as time dilation. As you accelerate through space, time itself slows down. For an observer moving near the speed of light, biological aging, chemical reactions, and the movement of atoms all decelerate relative to the rest of the universe. While special relativity provides the geometric framework for this effect, it mirrors a specific computational strategy. In a massive open-world video game, when a character moves faster than the processor can render the environment, the system drops the local frame rate to prevent a total crash. Viewed as a simulation, time dilation is a computational failsafe. When an object approaches the maximum processing speed of the CPU, the system forces that local sector to lag. You aren't just moving through time, you are causing the rendering engine to buffer. If the speed of light is the limit of the processor, then we must look for the resolution of the cosmic monitor. Historically, we believed space was continuous, that we could zoom from atoms into subatomic particles endlessly. Quantum mechanics contradicts this. It defines an absolute minimum unit of distance called the Planck length. To understand this scale, if a single atom were expanded to the size of the entire observable universe, a Planck length would be the size of a single atom within that universe. Mathematics indicates that anything smaller than a Planck length has no physical meaning. At this scale, the concept of a location in space ceases to exist. Space cannot be divided any further. This is the exact behavior of a digital pixel. No matter how high the resolution of an image, you eventually hit a single, indivisible block of color. This suggests that our reality is not a smooth fabric. At its foundational floor, the universe is built in finite, 3D blocks of data. It is a pixelated grid. When we treat the universe as code, deep space anomalies that baffle traditional physics become more recognizable. Quantum entanglement, for example, allows two particles to stay perfectly synchronized across billions of light years. If you alter the spin of one particle, its partner changes instantly, regardless of the distance between them. This occurs in 0 seconds, appearing to bypass the universal speed limit. In a physical vacuum, this is impossible. But in a digital system, two objects on opposite sides of a map can share the same memory address. When you update the code for one, the other reflects that change, because at the level of the source code, they are the same piece of data. We see a similar breakdown of physics in black holes. These are regions of infinite density, where our current understanding of time and space effectively stops working. A singularity occurs when the mass in a single coordinate exceeds what the equations of spacetime can calculate, resulting in an undefined value. In any other complex software, an undefined variable represents a critical error that must be contained. The simulation responds by cordoning off these sectors behind an event horizon. Time stops at the edge of a black hole because the rendering engine has halted all processing for that specific corrupted data sector. The stress test is complete. We have identified a maximum clock speed, a minimum pixel size, a mechanism for local lag, and zones where calculation errors freeze the rendering process. These constraints suggest that the physical world is a biological interpretation of a mathematically structured system. The structures we interpret as the laws of nature align with the architectural requirements of a digital environment. We are observing the parameters of a closed system. This realization shifts our focus to the nature of the hardware. We must consider the purpose of the simulation and the consequences for our reality if the system is ever powered down. Look closely at the world around you. Once you recognize the mathematical grid beneath the surface, the illusion of a smooth, organic universe disappears. You are looking at the code.